So the first key feature I'd like to take a look at is multi-join. Now before we go and have a look at this key feature, let's have a look at the problem that it's going to solve. So here we have a concrete frame. And if I zoom into a particular area of it, for example where we have this element coming up through here, this element has been modelled from the ground floor all the way up to the 4th floor here. Now that causes us a bit of a problem. The first problem it's going to cause us is a double count on the concrete. So you can see here that we have overlapping volume between the column and the floor slab. So across the entire model here, we could end up with many more cubic meters of concrete than we actually require. So that's the first problem. To have a look at that in a bit more detail, what I'm going to do is select this floor slab here and we'll isolate the element. Now take note here that the isolated element in this floor has no notches or penetrations through it. So it's a continuous part. The only penetration we've got is this area here for the core. Okay, the second problem it causes us is with drawings. So I'm going to open up our ground floor plan and you can see here that we have a cross section going through the core. Let's take a look at that cross section. And if we zoom into the drawing, you can see here that we have floor slabs and walls. And because they're intersecting without a join, we have this double count of line work. Now, it really makes the drawings look quite poor. So we need to really solve this problem, both from a volumes point of view and also to make better looking drawings. So this is where the tool comes in. Now, of course, we do have tools in Revit that we could use for this. I have a join tool over here. And yes, it does have a multiple join option, but it would still be time consuming to pick the various different elements and then window select all of the items. So here, if we go to our Excitech Toolkit, here we have multi-join. Now, in order for this to work, what you first have to do is select all of the elements that you want to join. So I'm going to do that first. Select the multi-join tool. And once the tool loads up, you can now see that we have two panes. The first window over here is for the first priority. So this is going to be the highest priority, or the things that we want to take precedence. So for example, if we think about a concrete structure, we might want the columns to penetrate through the floor slab. You know, for example, if we're putting reinforcement bar into the columns, the reinforcement bar wants to be continuous through the column and not the slab. So what I'm going to do here is select all of those items to be the first priority. When it comes to the second priority, i.e. these are the elements that we don't mind having notches or penetrations through, I'm going to go through here and say floors and also structural foundations. Now you'll also notice there's a couple more options down here. I have join only if geometry overlaps, which is quite good. If I've got a bit of geometry that butts up to another piece of geometry, I don't necessarily want to join it. And over here, it's going to override any existing joins that I've tried to put into the model. So that's good. So we'll now go ahead and ask our toolkit here to go ahead and join all of those concrete elements. So once these are joined, we'll inspect the 3D model and we'll go ahead and look at the effect of our drawings. So that's now done. Yeah, and that's done across almost 200 elements there. So let's zoom in and inspect the results. So now, if I select my column element over here, you can see here that we clearly have penetrations through the floor slab, which is great. If I now select the slab, the same slab we isolated earlier on, and we go back into Isolate Element, you can now see that we have notches and penetrations inside our slab. So the columns and walls are now taking priority. Let's also now take a look at our section. So we'll go to Section through the core. And we can see here that we've got a much higher quality drawing because these elements are again joined. So the wall is taking priority. It's a continuous element going up through the structure and the floor slabs are butting up or casting in to that wall. Okay, so that's clearly a very productive tool. The next key feature that we're going to have a look at is going to be a combination of tools to help us achieve a particular task. We're going to start working with foundations. So in our same concrete model, let's go into our piling layout. So you'll notice here that we have arrangements of piles. So we've got a 4 pile cap arrangement there, 3 pile cap. These are singular piles supporting our core. And you can see down over here we have twin pile arrangements. Okay, so what we want to better do with these is the first thing is going to be to go ahead and tag them. Now, of course, I can tag all elements in the model, but quite often what happens is when you tag these elements, the tag would end up right over the center of the element, which might not be appropriate. I might want to have a bit of an offset from the tag. So we have some great tools that we can use for this. Now, to start off, what I'm going to do is go ahead and select all of these piles in the entire project. So they're all of the piles selected. We'll go back to our Excitech Toolkit. And what we're going to do here is use Create Tags tool. Now, the great thing with this is we can actually save definitions if we want to, and then record those at will. So I can have a number of different definitions set up and record those for different project uses. So in this case here, I'm going to say pile tags. It's going to be relating to structural foundations. The tag orientation is going to be horizontal. This is the tag family I want to use. Now notice here we can inherit leaders as well, which could be quite useful. And then we can tell it to produce an offset in the X, Y, or Z axes. Now the offset is in real world units, so I'm going to offset these tags 500 millimeters in 1:1 units. Okay, so if we go ahead and create the tags, you'll see the tags will be created, but they will have that 500 millimeter offset from the piles. So clearly there, that's a really productive and quick and easy tool to use. Now, the second tool we're going to actually take a look at is going to help us with the physical numbering of these piles. So you'll notice here that I have quite a good piling numbering strategy. So P1, P2, P3, P4, for all of those piles within that 4-pile cap. Then of course over here you can see, following in the same analogy, we have pile 5, 6 and 7, again grouped within the 3-pile cap. Now that's quite hard to achieve manually. So what we're going to do is we're going to have a look at another tool we can use, which will allow us to kind of number these items. So you'll see here that we've got something called renumber mark parameter. So I'm going to go into this here, and if we just observe the last pile number we used, it was pile number 47. So what's going to happen here is you can see I'm prefixing these with a P. If I come down to the initial index in here, it's going to be 48. Yep. And now I want to increment those at 1 unit increments. Okay, and this will force override if I've already got marks on my piles. And then I'll click on mark. So now we can actually start to go through and sequentially pick the piles. Now again, it's still not fully automatic. It will still take a reasonable amount of time to do, but it's a lot quicker than doing it manually. Okay. Now, the last element of this is going to be to put out a piling schedule with eastings, northings and cutoff levels. So again, our toolkit can help with that. So what we'll see here is we've got a little drop down under Analyze. One of the great tools we've got in here is the insertion point of families. So once again, I'm going to go ahead and select all of my piles in the project. So there we have it. We'll go to our Excitech Toolkit, Analyze, and choose Insertion. So what I'm going to ask the toolkit to pull out the coordinates from is going to be the survey point. So this project has already been coordinated to OS coordinates. So we want to use survey point here. And if we click OK, our toolkit has now added in the eastings and northings and Z level of each element. So if I go ahead and pick pile 3, for example, in here, you can see there is pile 3. And you can see here that we have the X coordinate, the Y coordinate, and the Z coordinate. Now, also, what it does is it gives us the same set of coordinates for the top of the element. So if we wanted to do this for structural columns and have the base and the top recorded, this would be a really useful tool to enable us to produce that. My third key feature with the Excitech Toolkit is to look at the productivity tools that can help us when we're working with reinforcement. So one of my first annoyances with Revit is that if I want to make reinforcement bar visible, it's quite a complicated process. Inside this slab here, if I switch this to wireframe view, you can see that I have lots of reinforcement bar in here. And if I want to make all of this kind of visible, I've first got to select everything in the view. I've then got to filter just the structural rebar, like so. In the Properties palette, I've then got to click on View Visibility. Then I've got to locate the active view, which in this case is 3D, and then I'd have to say View Unobscured and View as a Solid. I can then put the shading back on, and you'll see now I can view my bar as solid. The problem with that process is I need to do that for each new piece of reinforcement bar that I add in, and that can become quite time consuming. So a better way to do it is to use our Excitech Toolkit. Now you'll see under the reinforcement panel here, we have a dedicated tool to control the visibility of a reinforcement bar. So for example, if I go back to make unobscured, I can do that with a single click of a button. So now, to go back to the state we were previously in, what I could do is just say, right, let's make all the bar unobscured. That just shows it up as wireframe. If I take the thick lines off, you can see that easier now. And then make solid. Yeah, 2 clicks of a button, much simpler. So that's a very useful tool when working with reinforcement. Okay, so we'll now take a look at a plan view on our slab. So you can now see that we've got most of the details in. I'll just put the thick lines on so we can see the reinforcement bars in a bit more detail. Now, the second tool I want to show you in here is going to be under selection, and it's this filter tool over here. This is pretty useful. What it does, when we go to our filter tool here, you can see that we can decide on the grouping order for our filter. So I could say by category, and you can see now I've got a count of how many elements are on each of those categories, or in this case, category and properties. So we want to really be working with structural rebar. Now, if I expand that, this is really cool. You can see in here that I have 2 reinforcement groups in here, both using shape 00. And then these are the properties for that particular element. So now I'm going to say, right, well, bar leg length A, what I want to do here is find all the values that are lower than, let's say 6 meters, and click OK. And you can now see that filter then makes a selection set of those elements, so I can very easily visualize them. And of course, if I come down to the actual leg length of that bar, you can see, yep, they're 6 meters. Another useful tool is this modeless filter tool in here. Now, what we can do with this is we can start to drill down through particular data sets. Let's say that I want to go and find all of my shapecode 21s, for example. I can just simply click 21 and you'll see it's selected all of the shapecode 21s in the model. What that then means is I can come through and start to add in my tagging information into that. So if I come up to the top here, you can see that we've got rebar layer and rebar comments. If I go to rebar comments, I'm going to type in here L bars. And of course, what will happen now is that's now going to update all of my labels in here. So you can now see all of my labels have updated and my bending schedule would have updated as well. Talking of bending schedules, if we go down to our schedules and quantities in here, you can see I've got a bar bending schedule. All looks pretty reasonable. It's to 866/2005, but a lot of fabricators will ask for this in an Excel sheet, or you've maybe been asked to deliver your bar bending schedule in Excel format. So once again, we can go back to our Excitech Toolkit and we can use our BIM query tool. Now this has many uses, but for reinforcement, it can be very useful just to grab the bar bending schedule. So in here, you can see that I have a pull down for schedules. In this example, I'm just going to say go and get the first sheet in there. Okay, so there's my bending schedule. There's one of the bending schedules in there. Now, in actual fact, the reason why that's not the original bending schedule's not come up is because it's open. So I'm just going to close that, and we'll go back to our BIM query tool again. Okay, so this time we'll go back in here, and now we can get the first sheet. So you can now see it's pulled all of that across into this environment here, and then very simply I can just hit this Save as Excel. Now of course if there's any columns that we don't require, we can just remove those. So I could just say delete that column there, yep, and then save this out as Excel, and the job is done.